So now we've talked about the theory. Now let's take the theory and put it to practice. And so the next stage is let's do a lab demonstration. And what we've done is we have this warm plate, and the warm plate is set to a temperature that's similar to when you start to perspire at 35 degrees Celsius or 96 degrees Fahrenheit. And we have this plate and we have our layered system on the plate. On one side we have a competitive system where we have a competitive base layer with a competitive outer shell. And on the other side we have the Cocona system where we have the Cocona mover layer with the Cocona protector layer. And what we're going to show is that when you start to perspire, how long does it take to get rid of that moisture? Because really what matters is when you perspire, you don't want to just move the moisture, you want to remove the moisture. If you just move the moisture, it's still part of your inner climate. You want to remove it, and the only way you can remove the moisture is by converting it from a liquid over to a vapor. And the way we do that is we increase the evaporation rate. And so what I'm going to show in this demonstration is three things. I'm going to put a drop for the competitive layer. I'll put a drop just on your skin, so that's just like if it was on your skin by itself. And then, to be fair, I'm going to put 3 drops on the Cocona side because we don't want to give the competition too much, grief. So now I've put my garment, I'm starting to sweat into my garment, and this is what's going to happen if water was just on my skin. This is on the competitive side, and this is on the Cocona side. What's important now is vapor needs to leave the system. And so that liquid has to convert to vapor. Well, how do we know the vapor's leaving? So I'm going to put some watch glasses on, and we're going to see the vapor actually condense onto the watch glasses. And that's going to show us whether vapor's leaving the system or not. Notice how large the circle is of the vapor condensing. Compare the two sides. Compare the competitive side versus the Cocona side. What's happening is, on the Cocona side, we're able to move the moisture and remove it. The evidence of the removal part is the vapor condensation. Well, let's look under the Cocona side. You can see that the Cocona has wicked out and moved the moisture into a nice big circle, and it's pulled it off the skin. When we look at the competitive side, you see that it's wicked out the moisture, but the moisture is still, part of the moisture is still on your skin. So let's check back in on our hot plate, and let's see. You can see that the water that's just on the skin is still there. But if we go over to the Cocona layer, we notice there's no water on the skin, there's no water in the mover layer, and there's no water on the protector layer. Let's see how our competitor did. Remember now that the Cocona side had 3 drops, the competitor side had only 1 drop, and our skin only had 1 drop. So you can see the moisture is still on the fabric, still on the protector layer. And so what system would you rather have? The wet system or the dry system?